In our last video, we talked on addition and subtraction of polar form, okay, of complex numbers in polar form, where we had this question. Okay, so the first thing we had to do was to convert each of the complex numbers into Cartesian form, and thereafter we perform the arithmetic operation, addition and subtraction on it, and then we now convert it back to polar form. Okay, so in this video now we'll be talking on how to multiply and divide complex number which are in polar form. So let's take for instance, let's create a theory. Let's take for instance we have a complex number z1 to be equals to r1 argument theta 1. Okay, and also we have z2 to be r2 argument theta 2. So in this case we want to multiply and we want to divide. Okay, so the key is very simple. In multiplication, in multiplication we multiply the modulus and add the angles, while in division we divide the modulus and subtract the angles. So given that we have z1 to be equals to r1 theta 1 and z2 to be r2 argument theta 2, we can say we want to evaluate z1 z2. Okay, since we're in polar form, all we just have to do is to multiply the r's. That means we have r1 multiplied by r2 and add the angle to be theta 1 plus theta 2. Right? And if we are to divide z1 divided by z2, all we just have to do is to divide the modulus. That will give us r1 divided by r2 and subtract the angle theta 1 minus theta 2. So with our understanding on this, let's take two quick examples on how to add, how to multiply and divide complex numbers in polar form. So let's take for instance we have number one, that z1 is equals to 8 argument 65 degrees and z2 is equals to 4 argument 23 degrees. We are asked to find z1, z2 and z1 divided by z2. Okay, so in this case the r1 z1 is given that z1 is equals to 8 argument 65 degrees. So we are saying that 8 is equals to r1 and 65 is equals to theta 1. And for z2, which is 4 argument 23 degrees, we're saying 4 is equal to r2 and 23 degrees is equals to theta 2. So in essence, we know that z1, z2, and in multiplication, we are multiplying the r's and adding the angles. And in division, we are dividing the modulus, that's the r, and subtracting the angles. So z1, z2 will be equals to r1 multiplied by r2 argument theta 1 plus theta 2. So in essence, we are saying r1, which is 8, as we've seen here, multiplied by r2, which is 4, as we have here, argument theta 1, which is 65, and argument 2, which is 23 degrees. Now in essence, this will give us 32 argument 88 degrees. Now we can also want to evaluate Z1 divided by Z2. And in division of complex number in polar form, we are going to divide the modulus and subtract the angles. So our R1, which is 8, is going to divide our R2, going to be divided by our R2, which is 4. Our argument 1, that's theta 1, which is 65. We'll subtract from our theta 2, which is 23 degrees. So in essence, this will give us 2 argument 42 degrees. Okay. So division and multiplication in polar form is actually quite easier than in Cartesian form. As well that addition and subtraction in Cartesian form is quite easier than in polar form. Now, let's take another illustration. We recall that Z1 is equals to R1 argument theta 1 and Z2 is equals to R2 argument theta 2. Now, and we can also illustrate that Z1 is equals to R1 into cos theta 1 plus I sine theta 2 sine theta 1, and Z2 can be given as R2 into cos theta 1 plus I theta 2 plus I sine theta 2. Now we might be given this question in another format. Okay, so let's go back and say that Z1 is equals to 8 argument 65 degrees and Z2 is equals to 4 argument 23 degrees. And since Z1 can be also be written as 8 into cos 65 degrees plus I sine 65 degrees, and Z2 can also be written as 4 into cos 23 degrees plus I sine 23 degrees. Now, the same thing goes on where we have to divide, or let's divide first before multiply. In division, we divide the modulus and then we subtract the angle. So in essence, Z1 over Z2 is saying we have 8 into cos 65 degrees plus I sine 65 degrees divided by 4 into cos 23 degrees plus I sine 23 degrees. Now we divide the R. Since we are dividing, we divide the R and then we subtract the angles. In essence, we divide this, as 8 divided by 4, we have 2, and then we subtract the angle. So we subtract 65 from 20, we subtract 23 from 65 plus I sine, and we subtract 65, 23 again from 65. Now this will give us 2 into cos 65 degrees minus 23 degrees will give us 42 degrees plus I sine 42 degrees. Now you might want to hold on, pause the video and want to try Z1, Z2, Z1, Z2. Okay, so in Z1, Z2 we multiply the R and add the angle, so that will be 8 times 4 into cos 65 degrees plus 23 degrees plus I sine 65 degrees plus 23 degrees. And this will give us 32 into cos 88 degrees plus I sine 88 degrees. Now, after we have been able to multiply and divide two complex numbers in polar form, how about when we have three or more complex numbers and we want to multiply or divide in that nature? Let's take for instance, I have z1 is equals to r1 argument theta1, z2 is r2 argument theta2, z3 is r3 argument theta3. In this case, we want to evaluate z1, z2, z3, and z1. Okay, we can just multiply z1, z2, and z3. So in z1, z2, and z3, we are multiplying. We are going to multiply the r, just as the principle we have here, multiply the r's and add the angles. So in that sense, we are going to multiply the 3 modulus and add the 3 angles. Okay, so let's take for instance, we have z1 to be equals to 4 cos 20 degrees plus I sine 20 degrees, and z2 is equals to 3 cos 30 degrees plus I sine 30 degrees, and z3 is equals to 2 cos 40 degrees plus I sine 40 degrees. Now, all we'll have to do is to multiply the r's and add the angles. Add the angles. So we can reduce this further. Okay, we can say this is 4 arguments 20 degrees, this is 3 arguments 30 degrees, and finally this is 2 arguments 40 degrees. So in essence, this is our r1 and this is our theta1, this is our r2 and this is our theta2, and this is our r3, and this will be our theta3. So following the formula, z1, z2, z3 is equals to r1, r2, r3 arguments theta1 plus theta2 plus theta3. So we take our r1, which is 4, multiplied by our r2, which is 3, multiplied by our r3, which is 2. And then we can add the argument 20 degrees, 30 degrees, and 40 degrees. 20 degrees plus 30 degrees plus 40 degrees. And this will give us 24 argument 1, argument 90 degrees. And we can also rewrite this as 24 to cos 90 degrees plus I sine 90 degrees. So questions can come in any format. Okay, it can come in any format, and the principle remains the same. If we are dividing, we divide the r and subtract the angle, and if we are multiplying, we multiply the r's and add the angles together. So let's take for instance, we are asked to simplify. Let's call this question 3. We are asked to simplify 3 cos 143 degrees plus I sine 143 degrees multiplied by 4 into cos 57 degrees plus I sine 57 degrees. The question here is, what is the mode of operation here? We are multiplying and it is in polar form. So all we just have to do is to multiply the r's and thereafter add the angles. So in that case, multiplying the r's, we have 3 and 4. 3 multiplied by 4 and add the angles, 143 degrees plus 57 degrees plus I. We can also add this I. So this sine 143 degrees plus 57 degrees. So in essence, we will be having 12, because 3 times 4 is 12, cos 143 degrees plus 57 degrees is 200 degrees plus I sine 200 degrees. Okay. Also, we might be asked to evaluate finally for this video. Let's take a look at 10 cos 126 degrees plus I sine 126 degrees divided by 2 cos 72 degrees plus I sine 72 degrees. Remember, we are dividing, right? And in division, we divide the modulus and subtract the angles. So this will give us 10 divided by 2. Subtracting the angles, we have 126 degrees minus 72 degrees plus I sine 126 degrees minus 72 degrees. So in essence, this is going to give us 5 cos 54 degrees plus I sine 54 degrees. So we have been able to perform, so far we have been able to perform operations on Cartesian form. I'll be able to perform addition and subtraction, multiplication and division on both Cartesian form of polar number, of complex number, and polar form. And in our next video, we'll be talking about the exponential form of complex number and also the logarithm of complex number.